Okay. Welcome back, everybody. It's 1:30 out here in Breckenridge, Mountain Standard Time. And we have with us here on my left Greg Carbin from the Storm Prediction Center, and also Clark Payne from the National Weather Service's Warning Decision Training Branch from Norman, Oklahoma. So both of these gentlemen spoke this morning, had some great talks, and we're going to go over to the social media side and see if we have any online questions. We know we have some viewers out there. If any of you would like to ask any questions, please feel free to type them in. Sarah Maxwell is monitoring your questions, and then she will ask those questions live to Greg and also to Clark. And so I'm going to sort of drift out of the picture here, and if there isn't a first question, I actually had one for both Clark and Greg, and that was, as the Storm Prediction Center thinks about the warning activities, the severe weather that's possible out there, does dual polarized radar play in your forecasting at the capabilities at the Storm Prediction Center, or are you really going more with model output, ensemble output to get long lead time? But does dual pol radar play any role in that?
That just before coming out here, I worked an evening shift with mixed precipitation in the upper Midwest, light, but nonetheless, I was interested in what dual pol could do. I think the Davenport radar might have had the most of the precipitation in view. And I grabbed the cheat sheets real quick and went through the different products that are available from dual pol to discern what type of precipitation was falling, and then verified it at the surface with observations. So. We have a range of uses for data from forecast model information when we're looking for several days out. But once an event unfolds and is underway, observational data is a critical component for our decision making. And so the answer is absolutely dual pol plays a role in our operations.
Well, and I also think that there's I know in the research community, they're trying to use dual pol to initialize the models that are used to forecast the future. So I know that dual pol will be used for that as well.
Sounds great. I'm going to throw it over to Sarah Maxwell. She has a question from one of the online viewers.
Okay, this is for you, Greg. Could you elaborate a little bit more on your thoughts about warning fatigue? Because a lot of our media members in our audience have a lot of issues with warning fatigue and overwarning and the boy who cried wolf. Would you like to expand on what you're doing to help minimize that?
We had a very interesting discussion at the close of my talk this morning about that, and I was actually quite surprised. Some of the TV stations now determining thresholds for severe weather based on impacts, and I mentioned in my talk, I think a couple of times, about how the nature of weather is not deterministic, and it does not fit easily into bins or boxes. There is always going to be a level of uncertainty associated with all types of weather, and our challenge is to convey honestly our assessment of the threat. And when it gets down to it, you have to make this deterministic decision about something that is not necessarily 100% certain. So in a sense, we're never really going to solve the problem. We're always going to have false alarm. Just as I said this morning, there is no such thing as a perfect forecast. There will always be false alarm. We really walk a double-edged sword. We don't want too much of that, certainly. That's the cry wolf syndrome. But you don't want to pass up an opportunity to save lives. And so this is the dilemma. How do you accurately convey the threat when you're uncertain, so that people take actions they should take, given the impacts, and not do that too often, and have nothing come about. We walk that fine line in the Weather Service and other endeavors, and it's one that you're constantly refining, and it's one that you can get better at by doing verification. And so I think we do need to look at the metrics with respect to how often are we right when we warn for tornadoes. How often are we not? But not only that, how how far were we, perhaps, from having an event occur? That's probably the hardest question to answer of all. You never know how close you are. There are events that you may be right on the threshold of a major tornado. Issue the warning. That is the thing to do in those events. Tornado doesn't occur, thank goodness, but you never know how close you were. And so I don't think we'll ever necessarily remove false alarm completely, but constantly reassessing the accuracy and skill of these warnings and watches should be one way that we can get better and reduce these false alarms and improve the metrics for forecasting.
I have a question for you about, and I guess this would be more towards you, Greg. Can you make some comments on the value of satellite data in the Storm Prediction Center and how satellite data is used to help you make your decisions on either short-term or long-term forecasting? Because you know, satellites are a major expense, but they're also things that have to be planned so we don't have any gaps in satellite coverage. So if you could comment on that a little bit, that'd be great. And then maybe touch on what would a gap in satellite coverage mean if we were to lose some satellites and not have that input into the you know, Storm Prediction Center.
Well, first I'll talk a little bit about the wide variety of satellite data that goes into the weather and forecast challenge. I mean, we've got polar orbiter data, which we rarely, if ever, look at operationally in the SPC, but that's critically important to initializing the models. And then the geostationary satellites farther out there and more expensive and somewhat at risk for seeing gaps if we don't continue very expensive programs to have overlap in coverage. Those are the satellites that are utilized operationally, along with other, this is observational data. And observational data is absolutely critical to what we do. We need surface observations, we need radar data, we need satellite information, anything that gets us a little bit closer to what I would call truth. What is the atmosphere actually doing now? And the analogy that we use at the SPC is that our assessment of the atmosphere is very similar to one a medical doctor would take in diagnosing a patient. Before you can make a prognosis in a particular sickness, say, for a medical doctor, you need to understand the current state of your patient through diagnosis. And so satellite data provides a component of diagnosis that is unlike any other data and is a key component to that early process before you can even begin to forecast.
That sounds great. I appreciate that. And can you give a little bit of insight as to what would happen if we did not have satellite coverage? How would that impact your operation at the Storm Prediction Center?
Well, occasionally we do go into blackout. So, I mean, it's not like this hasn't happened. And you do occasionally see times of the year when the satellites need to be shut down for a while. And you're flying blind, at least for that component of the observational puzzle. In the lower atmosphere, there are some we can cover some of that gap with radar and with ACARS, aircraft data, balloon data. Some of the information that we get from satellites as well can be temporarily filled in with this other data. But yeah, satellite data and radar data, I called them revolutionary this morning. Satellite technology and radar technology are revolutionary milestones in operational meteorology, and nobody doubts that. And to lose the geostationary data for any significant amount of time for the Storm Prediction Center would be a critical loss. And you know, we could go only so long, I think, before you would see the forecasts and warnings and watches suffering from the lack of that data.
And I'd like to shift, if I could, just for a second to you, Clark. When you were talking this morning about the dual pole radars and how they've really benefited the forecaster, how you can really tell the difference between that liquid and frozen precipitation. Can I ask you to look a little further out into the future and talk maybe a little bit about what might be next? You know, dual pole is just coming out, but what are some of the technologies that you're looking at that maybe in 5 years or 10 years or 15 years might be advancing our radar and observational capabilities?
Yeah, just after the talk this morning, I was talking with Greg and some other people about algorithms that are going to be coming out with dual pol. And right now, since dual pol is so new, we're stressing just the base data. We're stressing the basics right now and really getting people to understand that and notice all of the new things and exciting and confident things that they can get out of dual pol just by looking at the base data. However, there are some research out there that are going to maybe improve algorithms, such as one of them is the hydrometeor classification system. And right now we have one in place, and it does about 10 different classifications. It can do ice crystals, it can do snow, it can do rain, grapple, big drops, things like that. But as we learn more and more about dual pol, we're hoping to expand that hydrometeor classification. And for example, one of them is the large hail signature. I know I showed a couple examples today where the correlation coefficient dropped below 0.9, and that showed a large hail signature. Well, right now we don't have any algorithm to point that out, but it looks like there may be promise that we can do something like that to, help the forecaster. So I mean, there's definitely a lot of room for improvement, a lot of things that we just don't know yet with dual pol that we could hopefully learn in the future and advance what we're doing and just increase a forecaster's confidence beyond what they already have.
And is there anything in the form of technology beyond dual pol, or is like dual pol it? That's like the radar that we've been hoping for. We now have it. It's going to last us 15, 20 years. Is there something else that you're thinking about beyond that?
No, beyond dual pol, there's a radar called phased array radar. And instead of having a mechanical dish that spins around and around, it steers the beam electronically. And so we can scan the atmosphere much faster, and we can get volume scan updates on the order of minutes instead of, or like up on the order of a minute instead of 5 minutes like what we have now. And so phased array is probably the future of radar. However, and they're going to hopefully have dual pol along with phased array. Right now, dual pol is not in phased array, but they are working on getting that going. So hopefully, and that looks to be maybe, if I had to guess, don't quote me on this, but maybe 20 years down the road is when it looks like phased array may come in.
And we have an operational, quasi-operational phased array radar in Norman, and there are a number of research groups working with that radar. The interesting thing about phased array is it comes from the military. It's basically from the Aegis missile cruiser. Mm-hmm. It's a military radar that scans, like Clark said, electronically. And I think I've seen loops of some storms on this radar, and you see things in this data that we never even knew existed because of the update time on that. And I thought it was 20 seconds or 30 seconds.
Some of them can be that
scans.
quick.
So you're scanning very rapidly. And so let's keep our fingers crossed that that technology will come online in the next couple of decades.
That sounds great. I'd like to just widen out a little bit, and just for those who are watching online right now, Clark, if you could just describe to those folks that are watching right now, what does the Warning Decision Training Branch do? Because I don't think many people have really heard of that specific branch. They think of Norman, Oklahoma. They might think of the weather center there, which is fabulous. But what exactly does the Warning Decision Training Branch do?
Yeah, we're at the Weather Center in Norman. We're actually on the second floor in the corner, so we're even kind of hidden in Norman. But a lot of what we do is we train Weather Service forecasters as they come into the Weather Service how to use radar to issue warnings. And so we end up we have a course called the Distance Learning Operations course where they take about 120 hours of online training, and then they come in at the end of all that training for a 1-week residence course where we do simulations with them and show them how to use radar to make effective warning decisions. And then once they go through that course and they are basically tagged as, okay, you're now warning ready, and so you can go back to your office and you can issue a warning and be ready to go and become productive in the National Weather Service.
Now, do they then take that knowledge and train other people within their forecast office, or does all the forecast offices need to send people to Norman?
No, this is just kind of initial training. Every local forecast office, they do local training every year, and they can use what we call the weather event simulator, where they can grab the data themselves and then run it through their simulator there, and they can do local training so that they can do, because as a national, center, we don't know all the little nuances that go into warning decision making at every local forecast office. And so we let them do all the training post that. Now, we also have an advanced warning operations course that the forecasters, after taking the distance warning operations course, can take that to help just enforce those skills that they learned in the first course.
Sounds great. Greg, it's your turn now, because I know a lot of the folks that are watching and people that have talked to me, when I mention the Storm Prediction Center, they say, well, what does the Storm Prediction Center do? So it's a good opportunity to take maybe a couple of minutes just to describe, at a high level, what it is SPC does.
I'll be glad to. And as Clark was talking about the transition from intern to trained meteorologist, there are so many components involved in that. And the Weather Service, well, at least when I got in the Weather Service, you sort of had to move around the country to move up the chain. And when I got to SPC, I just stayed because it was hard to see anything greater than this for someone so interested in meteorology. The data's there, the people are there, the research is there. But the concept behind the Storm Prediction Center is relatively easy to explain. Think about different areas of the country that don't experience severe thunderstorms all that often. And really, the northern tier states, there may be a handful of events, if that, per year that would meet the criteria of a significant severe thunderstorm event. So you're a forecaster in that office. You may be in that office for 5, 10, 15 years before you actually are on the front line having to issue severe thunderstorm warnings or tornado warnings for your area. So how do you do that? Well, it's very difficult to maintain proficiency in that type of environment. So what you do is you task a core group of dedicated meteorologists with the problem of forecasting thunderstorms day in and day out, regardless of where they are in the country. And hopefully you keep them around long enough that they don't, go off and into other areas of interest. If you can maintain a cadre of very experienced severe storm meteorologists that can then be utilized by these local offices in the event that they have a severe weather episode come about. That's just that extra level of protection for those areas of the country that don't experience severe weather all that often. Now, there are many areas that do experience severe weather much more often. In the southern United States, for example, parts of Texas, Louisiana, Mississippi. What about those meteorologists? Well, they're on the front lines too. But we're there in support of those efforts that, when they go into high gear and operating in severe weather mode, or even if it's a couple days out, we're here watching the atmosphere unfold just like they are. And it's a form of confidence building, or basically, does my forecast match what this field office has, or vice versa? The field office is referring to our forecasts for guidance. I think you can we built relationships with the field office. It's a team effort, and we provide a critical role in terms of surveillance for severe weather events nationwide, and we're there when we're needed.
If you could elaborate on that, I do have one request online. Can you describe, and I'm going to expand his question a bit, expand how SPC differs from the other national centers, such as NHC and HPC?
Sure. And again, I talked about severe thunderstorms, tornadoes, large hail, high winds. And it really is the thunderstorm problem where SPC, formerly CELS, the Severe Local Storms Unit of the National Weather Service, got their start. And these events are small scale, relatively short-lived. They come about in pretty rapid pace. The development of a severe storm system generating a number of tornadoes it's here one day, gone the next. And so that's one focus. We also look at fire weather on a national, relatively large scale, but we provide insight into areas of the country that will experience dry, windy conditions or dry thunderstorms. In the West, they often have thunderstorms that produce very little rainfall, and in the summertime, they're a huge threat for wildfire starts, given the right conditions. So we're monitoring that as well. All of these events really require insight at relatively small scales. You're looking down, smaller scale than a medium-sized state. You're doing analysis on temperature, pressure, wind, boundaries, And so mesoanalysis comes in, and it's been recognized that these detailed meteorological analyses are critically important to understanding severe storm development and evolution, and that type of constant weather watch, continuous weather watch, is done at the SPC for these types of hazards, day in and day out, 24 hours a day. And again, I hope we hold on to the dedicated meteorologists and they don't go somewhere else, because really it is about experience. It is about doing this day in and day out and not always being right and trying to learn from mistakes that you might have missed something. And so people who are willing to be hit, knocked down by Mother Nature, come back into work the next day, try it again, and learn from it are the people that we're hoping to have work at SPC. And I think we got them.
Great, thanks. I wonder if I could go back to Clark, and if he could answer, because what we do here at the Weather and Climate Summit is bring the media and the science together. How often do you train the media partners who are using dual pole radar? And how are the TV stations rolling out dual pole or taking advantage of it themselves?
Yeah, that's a great question, because most of our funding comes from the federal government, and so most of our initiatives are focused on the National Weather Service. However, with the Weather Ready Nation and coming into having partnerships with local media and stuff, we are starting to branch out and try to do more outreach activities with the media. For example, with dual pole, we actually have an outreach course that can be used by the warning coordination meteorologists at the local offices that can then be used with the local media. And so we are trying to branch out and not just have our training focused only on National Weather Service forecasters, but also those people that are in the decision-making process with the Weather Service forecasters.
Do you have, just a follow-up to that, do you have specific workshops that the media does come to in the Norman or Oklahoma area, or are there other training courses held in conjunction with AMS, the annual AMS meeting, or things like that?
As the Warning Decision Training Branch, we do not have any conferences or workshops that are for the media. However, we have been involved with the AMS short course, where we did a dual pole training course that was for broadcaster meteorologists. But a lot of the broadcaster weather service relationship really comes down to the local offices and between the warning coordination meteorologist and the media there. And so what we have been trying to do is do more efforts to give those warning coordination meteorologists material that they can use when they do their training with the media.
I can get a shameless plug in, right? The Storm Prediction Center does do the annual National Severe Weather Workshop, where we have had Clark and others come in every year. The annual workshop's been going on about 10 years. Its primary focus was the media and emergency management and weather enthusiasts, other meteorologists, to try to bring them together for a couple of days and provide content about what's going on in the weather business. In recent years, I've been program chair of that, and what I've tried to do is I want meteorologists to understand the emergency management process too. I think it's critically important. This is not just a one-way street for communication. It's not just the meteorologists telling the broadcasters or emergency managers, here's the latest and greatest. It needs to be the other way around too. We need to hear from emergency managers. We need to hear from broadcasters about success stories or failures in the way that we've worked together. And so that's been my kind of working goal for the workshop the last few years. Now, change of venue this year, coming up March 10th through 12th. We have teamed up with the Oklahoma Department of Insurance, and we will be a component of what's called the National Tornado Summit. And that will take place in Oklahoma City at the Cox Convention Center. There will be an insurance component to this, where adjusters from all over the country will attend this industry conference to learn more about weather forecasting. And we're going to put on some workshops on societal impacts, on how people perceive warnings, and maybe even work a little bit on some of the enhanced Fujita scale, talk about improvements that we need in that system. So we're teaming up now and expanding even more the people who are interested in weather. It's going to be insurance. There will be emergency management content at this workshop, and there will be a broadcast component as well.
Greg, I know there's been some controversy related to this, and I'm sure you'd appreciate to have another sounding board on this. Would you, and if so, how would you have handled Sandy differently?
Well, I'm not. I'm not a tropical storm meteorologist, and I don't want to claim to be one. But I am a meteorologist, and I think I said during my talk this morning that I was obsessed with Sandy because Sandy was unlike any storm that I'd ever seen. And I think it was interesting that even though I was going through this process of trying to understand Sandy better, almost a sleepless process, I'll be honest. I didn't get very much sleep. I was constantly assessing what's going to come of this. But in the end, I think I kind of accepted it as any other storm, when in fact it was really fundamentally different from what we'd experienced before. And I think what we were trying to do is the best that we could do with the technologies we've had available to us. And I don't think anybody was trying to not do the best. Let me make that very clear right now. But this was an extremely challenging situation. There's no doubt about it. And the key, and probably as we move forward, the thing to take away from Sandy is how do we recognize these really out-of-the-box challenging situations ahead of time. And I don't know if you've heard of the concept, but I talked to Clark about it this afternoon, of the black swan, which is a highly improbable but highly impactful event. In many situations, you won't see it coming. And I think Sandy has some aspects of being a black swan.
I was going to pick up, Greg, on the question that Sarah asked before from one of the online viewers with regard to SPC. They also asked, how does SPC differ from the other centers? So you have, I guess, Climate Prediction Center,
Right.
the Hurricane, National Hurricane Center,
Right. Space Weather
Prediction
right.
Center,
Right.
all those centers.
Yeah. Well, again, our focus is on relatively short time scales. The focus is on hazardous weather in the form of tornadoes, large hail, damaging winds, wildfires, heavy snow or heavy precipitation events. The Hydrometeorological Prediction Center, and you'll hear from Dave Novak tomorrow morning, they're looking at the precipitation, larger scale synoptic weather systems out several days in advance, medium range forecasting. The Environmental Modeling Center is crucial to all of these centers and all of the National Weather Service offices, because that's the center that runs the computer models. You mentioned the Climate Prediction Center. They're looking several months down the road, a year out. Ocean Prediction Center is dealing with the offshore waters and oceans. And what else do we have? Aviation Weather Center. Their role is entirely geared toward the aviation system and how to better provide information to the FAA about airspace. And we heard the other day how critical that is. If air traffic increases as we expect it to, weather will become it's already an incredibly important aspect of the aviation system. And if you're going to be putting more air traffic out there, it becomes even more imperative that we have accurate forecasts and a better understanding of especially small-scale severe weather systems like squall lines that can shut down the eastern corridor in a matter of hours and throw the whole air system in chaos. So all these centers are specialized.
And do you, as SPC, work with the other centers, or do you interact with them only when conditions warrant? Or I guess the question really is, are the centers coordinated in some fashion when you need to come together to discuss a large event or something?
For the most part, yeah, and it would be in those areas where there is some, overlap. And I'll give you an example. We work with the Hurricane Center very closely on landfalling tropical cyclones with respect to the tornado threat. And so we will be coordinating the tornado threat with the Hurricane Center and the local National Weather Service offices for landfalling hurricanes and tropical storms. Aviation Weather Center, obviously, with their role in thunderstorms and convection in the airspace, very close relationship with them and sharing of products and ideas to how to better forecast. Not so much on, say, the marine areas. We're primarily focused to the terrestrial continental United States, but some of the offshore waters work. And we've recently begun discussions with the Climate Prediction Center, too, with respect to these longer range seasonal type severe weather outlooks as a possible product that would come out from that relationship.
Sounds great. Clark, I'd like to turn back to you for a second and ask you if you could give our online audience an update, if you know this, on the status of the dual polarized radars. Are they all completed? Is the rollout done? Are all the radars operational, or do we have still more to go?
No, we still have more to go, but by the end of either this spring or early summer, all of the National Weather Service WSR 88Ds should be upgraded to dual polarization. Right now, pretty much every radar in the CONUS is upgraded, except right along the Gulf Coast and some in the high plains in Nebraska and South Dakota. Those aren't upgraded, but for the most part, West Coast, East Coast, plains, pretty much anywhere you can look right now, you can find one that's upgraded. But by the end of this spring, early summer, we should have every single radar that's owned by the Weather Service, DoD, everything should be upgraded to dual pol.
So does that include Alaska, or does that not include Alaska?
That does include Alaska. So those
Hawaii.
will all be dual pol.
Hawaii as well.
Yep.
Okay. And so when you convert these radars to dual pol, do those meteorologists that are in those forecast offices, they then come back to the Warning Decision Training Branch to get training on using the dual pol capability? Is that right?
No, actually what ends up happening is everything was done distance this time. So they just take all of the online training courses. And then we've also sent out some DVDs that have case data on it, like what we looked at this morning, where they look at the data, they get to make a decision, and then a dual pol expert like myself or Paul Schlatter or someone at the Warning Decision Training Branch would then record themselves talking about that event and what they saw. And so the forecaster can then learn from what we've seen and what they've seen and get a better understanding of how they can use dual pol in operations. So it's all done distance. We did not have to do any in-residence portion with the dual pol ops course.
I think that's it. Sarah, do you have anyone else online that no other questions online? We've gone a little bit over 30 minutes, which is terrific. And I do want to remind everyone that is watching online, these videos will be made available on the Weather and Climate Summit YouTube page, and that will happen over the next couple of days. And so they'll be here and available for reference from here to eternity, I suspect. And so I really want to thank Clark Payne from the Warning Decision Training Branch and Greg Carbin,
Thank you.
the Warning Coordination Meteorologist for the Storm Prediction Center in Norman, Oklahoma. And we hope that those of you who are watching online now join us back tomorrow morning as we have yet another exciting series of events. You can see the agenda up here now for the first session starting at 8:30 after Dale Eck gives his weather briefing. We'll have forecasting extreme precipitation events, and that'll be really interesting. Dr. David Novak will join us. Greg mentioned the HPC, the Hydrometeorological Prediction Center. David has come out from the Washington area. They have a new building that they've been working in College Park now, which is pretty exciting as well. And then at 10:15, Dr. Jennifer Francis from Rutgers University is going to speak on the wacky weather and disappearing Arctic sea ice. Jennifer has done a lot of research. She was here last year, gave a presentation. It turned out that her presentation now has had almost 7,000 views, and her research is really taking off. Basically, with the disappearing Arctic ice, it seems to be altering the synoptic weather patterns and causing more extreme weather. So we'll be looking forward to that. And then again in the afternoon tomorrow from 1:30 to 2 o'clock, we'll have a live Q&A session with Dr. David Novak and Dr. Jennifer Francis. So thank you very much for joining us. We'll call this a day from Breckenridge, where it's all the way up to about a degree, I think. And so maybe a little bit warmer, almost in double digits, right? So thank you very much for joining us, and we'll see you back here tomorrow morning.